In the silent theater of the cosmos, the most profound stories are told in whispers. Imagine a faint signal, traveling for over a day to reach us, carrying secrets from a place no human has ever been. This is not science fiction. This is Voyager 2, a tiny spacecraft from the 20th century, rewriting our understanding of the universe. It sent back a message, a single, unexpected pattern in its data, shaking the foundations of astrophysics. This faint whisper suggests the space between stars is not as empty or hostile as we believed. Voyager 2, now over 20 billion kilometers from home, has forced us to question everything we thought we knew about the void. The universe, it seems, still has surprises. The story begins with a stream of numbers, transmitted by a machine built before the internet was common. For decades, Voyager 2 has been our silent emissary to the stars. Its instruments are eyes and ears in the interstellar medium. Recently, those instruments detected something baffling, a subtle, persistent dip in background cosmic radiation. At first, scientists thought it was a glitch, but the signal held steady. The journey of Voyager 2 is a testament to our curiosity, and now, the universe has sent us a puzzle that could reshape our place in the cosmos. This is the story of that clue, and our quest to understand it. Let's travel back to 1977. On a Florida launch pad, Voyager 2 and its twin, Voyager 1, began a journey that would outlast all expectations. Their mission to take advantage of a rare planetary alignment and give us our first close-up look at Jupiter and Saturn. Anything beyond that was a dream. Bolted to Voyager 2 is the Golden Record, a time capsule of Earth's sights, sounds, and greetings in 55 languages. Voyager 2 is more than a machine, it's an ambassador for our planet. Powered by a radioisotope generator, it's still operating today, measuring the magnetic fields, plasma, and cosmic rays of deep space. A radio signal from Voyager 2 now takes over 18 hours to reach us. It has survived freezing temperatures, radiation, and technical glitches, flying past Jupiter, Saturn, Uranus, and Neptune. It's the only spacecraft to visit the ice giants, and after its planetary tour, it just kept going, into the unknown. Voyager 2's journey is a story of resilience and human ingenuity. It went farther than anyone thought possible. Before this latest discovery, Voyager 2 had already transformed our understanding of the solar system. Its flybys revealed volcanic moons, new rings, and storms on distant planets. It gave us the only close-up data on Uranus and Neptune, shaping our view of planetary diversity. After the planetary tour, Voyager 2 entered the outer solar system, dominated by the solar wind. In November 2018, it crossed the heliopause, officially entering interstellar space. There, it measured a sharp drop in solar particles and a rise in galactic cosmic rays. Voyager 2 became our first direct sensor in the cosmic sea, measuring the density and magnetic field of the interstellar medium. The data was predictable until early 2025, when everything changed. The probe sent back something no one expected. The discovery began quietly, as a puzzle in NASA's Deep Space Network. Scientists noticed a persistent change in Voyager 2's cosmic ray subsystem, a steady dip in high-energy particles. At first, they suspected a malfunction, but diagnostics showed the spacecraft was healthy. The only thing that had changed was the universe around it. The team checked the plasma wave subsystem and found a faint, corresponding oscillation, a new wave pattern in the plasma. It was as if Voyager 2 had entered a region where space itself vibrated differently. The anomalies were linked, a dip in cosmic rays and a new plasma wave. This wasn't a glitch, it was a genuine environmental change. Voyager 2 had flown into something new. For decades, we thought interstellar space was uniform, a thin soup of gas, dust, and radiation. But this data pointed to a large, unknown structure in the interstellar medium. Something was damping cosmic rays and making the plasma hum. It was a signal not in the script, an observation no theory had predicted. Our silent wanderer had stumbled upon a new cosmic mystery. The universe had just become more interesting. Scientists named the phenomenon a zonal attenuation field, a vast region of space that acts as a natural shield, filtering out dangerous cosmic rays. Nothing in astrophysics predicted such a structure. The leading theory, the field is created by the galactic magnetic field interacting with a dense cloud of interstellar dust and gas. Magnetic field lines become tangled, forming a net that deflects cosmic rays. The plasma oscillations Voyager 2 detected are the sound of this interaction. To confirm, scientists commanded Voyager 2 to roll, changing its orientation. The cosmic ray count changed with direction, confirming the effect was external and structured. The field is immense, hundreds of astronomical units wide. It's a colossal, invisible bubble of safety in the interstellar void. Voyager 2 just happened to pass through this cosmic oasis. Finding it was pure serendipity. It's a humbling reminder of how much there is to discover. Sometimes, discovery is just being in the right place at the right time. The zonal attenuation field has profound implications for the search for life. High-energy cosmic rays can destroy the building blocks of life before they form. If these fields are common, they could act as cosmic nurseries, regions where radiation is lower and complex chemistry can flourish. Inside these protective bubbles, the conditions for life's origins improve dramatically. These fields could be the missing ingredient that makes a galaxy habitable. Planetary systems forming within these zones would have a better chance of developing life. The search for extraterrestrial intelligence may now focus on stars inside these fields. We can use radio telescopes to find their plasma waves and magnetic signatures. Once identified, we can target telescopes like James Webb to search for biosignatures on planets within. Instead of searching randomly, we can hunt in regions where the odds for life are higher. It's a game changer. The discovery has sparked both excitement and skepticism. Physicists and astronomers worldwide are racing to understand the data. Dr. Fatima Al-Jamil called it the most significant in situ discovery of the century. It opens new avenues for research, from galactic dynamics to the search for life. Teams globally are seeking corroborating evidence, igniting a wave of collaboration. But some urge caution. Dr. Marcus Thorne notes the data comes from a single point, a 48-year-old instrument. He suggests it could be a local phenomenon, not a vast field. Extraordinary claims require extraordinary evidence. The debate is healthy, pushing both sides to strengthen their arguments. All eyes are on Voyager 2's next data. The coming years will be critical in settling this cosmic debate. The zonal attenuation field discovery has energized plans for future interstellar missions. Proposals for new probes now have a clear target, the nearest attenuation field. Concepts like the Cosmic Mapper, 3 probes flying in formation, are being drafted to map these structures in 3D. Another idea, a probe designed to analyze the dust and gas within a field for organic molecules. The implications extend to our own solar system. Could such a field have passed through in the past, influencing life on Earth? Scientists will search geological records for evidence of ancient field crossings. This is a powerful argument for curiosity-driven science. Voyager 2 wasn't sent to find a zonal attenuation field, but it did. The most important discoveries are often the ones we weren't looking for. Exploration remains our most powerful tool for expanding knowledge. We stand at a remarkable moment in cosmic discovery. Voyager 2, a voice from the 70s, has revealed the universe is more structured and hospitable than we knew. The zonal attenuation field changes our map of the cosmos. Vast, invisible oases sheltering life's chemistry. The empty space between stars is not so empty after all. Science begins with a tiny anomaly, grows through analysis and debate, and leads to new understanding. Now, new questions arise. How many fields are there? Do they nurture life? This story is about the human spirit of exploration. Voyager 2 carries a piece of all of us, and in return, it has sent us a profound new mystery. We live in a universe still largely unknown, with the greatest adventures ahead. The little probe continues its journey, sending back postcards from a new world. We glimpse a hidden cosmic landscape, left with more questions than answers. It forces us to look at the night sky with fresh eyes, wondering what secrets lie in the darkness. If the universe builds safe harbors for life, how many ships have set sail?